This is Geometry Lesson 2-5, Distance Between Points. Our objective today is to find the distance between 2 points with and without a graph. You can see what the homework looks like over here. These are the problems that are without a graph. These are the problems that are with a graph. All right, so let's dive in. In example 1, I want to find the distance between these 2 points, 2,5 right here and 5,3 right here. So if I'm looking at a graph, it is easier with a graph, I think. I want to find this distance if I connect these 2 points with a straight line, and it does need to be a straight line. And at first, it might seem like you just count the diagonal. You count 1, 2, 3, 4-ish pieces of the diagonals. The problem is this piece of the diagonal is not the same as that piece of the diagonal, and we haven't considered the fact that different diagonals have different lengths. So like this diagonal is not as long as this diagonal, so that's not a good method. And I'll give you the solution because I'm awesome. You use Pythagorean theorem. So if I make this into a right triangle, check this out. I know that this side of the triangle is 2, and I know that this side of the triangle is 3, and I can actually calculate what this length is by calling it c. You might remember doing a squared plus b squared is equal to c squared, and that is exactly what I'm going to do. You use the fact that when I have a right triangle, it gives you permission to use a, b, c. Let's say c is the hypotenuse, so I'll label these things so that we have them for the notes. C is going to be called the hypotenuse, and A and B are both going to be called the legs. If I do any sort of leg squared plus another leg squared, and it doesn't matter the order, that will always be equal to the hypotenuse squared. So what we can do is we can plug in to find C. We can find the exact length of C, and we don't have to worry about what diagonal length it is. And this is true for most all of mathematics, even in higher dimensions. Whenever we're trying to find the distance something is in 3D or 4D or whatever space, you just look at the components. You look at the y component, the x component, and then you use some form of Pythagorean theorem. So let's plug in. I have 2 for my A, and I have 3 for my B, so that's supposed to be 2, and that's going to be equal to c squared. So what is 2 squared? This 2 squared means 2 times 2, and 2 times 2 is 4, so I'm going to say 4 plus, okay, what's 3 squared? 3 times 3 is 9. This is going to be equal to c squared. And I can simplify 4 plus 9, that's going to be 13, which is equal to c squared. And now this is the tricky bit. How do I get rid of this square? Because I want to get c by itself, and I need to undo a power of 2. You might remember that the way that we undo a power of 2 is by square rooting. If I square root the right-hand side, what's left over is just c, because the square and the square root cancel each other out. But I can't just square root the right-hand side and not do anything to the left-hand side. I have to also square root the left-hand side. So I'm going to square root the left-hand side, and I get this answer, the square root of 13 is equal to c. And that is the length. So I don't know exactly what square root of 13 is. I know that the square root of 16 is 4, so this is probably a number a little bit less than 4, but that is our answer. Go ahead and box that. C is equal to the square root of 13. There is one slight problem with this, which is while this works for distances because distances are always positive, in Algebra 2, we'll see, and I think we've already talked about this in Algebra 1 as well, normally whenever we take the square root of a number, we have to have a plus or minus out in front because it's usually solving something that looks like this. This is kind of trivial, but it will affect us later, so I want to talk about it. So if I have some sort of question that says, what number squared gives you 16? And the answer most people state is yes. Clearly that number is 4 because 4 times 4 is 16. Well, you're half right, and if you have a 50% in the class, that's technically an F. You also need to have the fact that x is also equal to negative 4 to account for both the positive and the negative possibility for the solution. Whenever I have something squared, we always do a plus or a minus whenever we square root to account for the fact that it could be a positive or a negative 4. So the reason that I'm ignoring that step over here where I don't do our plus or minus is because I know the domain. I know that I'm not allowed to be a negative. How do you walk a negative 13 steps? Well, you could say, oh, you just walk it backwards. No, you're still walking 13 steps. That is a positive distance. That positive distance is being walked backwards. Distance in everything is always positive. So I ignored the fact that we could have been negative here, and I just went on and took the square root. But that behavior of simply taking square roots to undo squares is dangerous in Algebra 2, and I'm just giving you a warning for next year. All right, so we have the general idea. You're always going to be using Pythagorean theorem to solve each of these problems. You break it down into the y component, you break it down into the x component, plug them into a and b, doesn't matter the order, add them up, and then square root it, and you'll always get the answer. That is our procedure, and I want to formalize that by writing it down in our notes. So here's our procedure. You're going to be doing the following steps. First, you're going to be find the, I'm just going to call this the change in x. And then step 2, you're going to find the change in y, how much y change. And if you don't like my notation, you can add to your notes that the triangle here means change. I'll put some air quotes on this. So find the change in x, find the change in y, and then you're plugging into Pythagorean theorem. So I'll say step 3, plug into this a squared plus b squared is equal to c squared, and that has a name. This thing is called the Pythagorean theorem. And once you plug it in, you will do step 4, which is to solve. Solve for c, and as a hint here, I will say last step will be a square root that you don't have to worry about with a negative. As an added hint again for step number 3, you can say that delta x is equal to a. You don't have to, it could be b. You could say delta x is equal to b, and you're still correct, but I'm just going to make it simple for the notes. You can say delta x is equal to a, and delta y is going to be equal to b. I'm using this word delta because that's technically the symbol name. This triangle symbol is called a delta. But I can read this as put the change in x as a, put the change in y as b. All right, so those are our steps. Let's do one final example without a graph, and let's see if this thing can still work. So let's do example 2 and show you how fast I can go. So I'm going to make up a problem on the spot. So find distance between, let's say, -3, -8, and let's make it slightly big, 5, -1. Okay, so how would I do this? I first find the change in x. How much do we change to get from -3 to 5? And there's 2 ways of doing that. You can just do it logically and say, okay, well, I was at -3 and I had to go 1, 2, 3 to the right to get to 0, and then another 5 to the right, 1, 2, 3, 4, 5 to the right to get to +5. So this is a total change of +8. If you don't like that method, you can just say one minus the other. You can always have this pattern of saying do the right side minus the left side. So this is the same thing as saying if the right side is 5, then you subtract the left side, subtract a -3. Whenever you have a double negative here, that really means add, and this is the same thing as 5 plus 3. So that was the change in x. We found the change in x to be +8. And then you need to find the change in y. So how much did you change to get from 8 to -1? And again, you can use logic here. This is my strategy. I use logic and I say, okay, if I'm down 8 and I need to get just to down 1, I'm really, really far underground. I need to almost break the surface and get to the top. I'm thinking like 0 is sea level. So I need to climb up a ladder to get from 8, and I'm going to climb up to get to 1, which means I'm changing by a positive amount. I'm probably changing by +7. I think that a -8 plus 7 will get to a -1. And again, if you don't like this method, you can just do right minus left. So if I'm doing right minus left, which is the same thing that I did right here, this is the right side minus the left side. If I'm doing that again, if I'm doing the right side minus the left side, that's the same thing as doing this. It's saying -1 minus negative 8, which is turning into negative 1 plus 8 because we have a double negative again. Negative 1 plus 8 is the same thing as plus 7. So again, I'm showing you that you can still get positive 7. You can get positive 7. You can still get, I never actually checked this one down here, but 5 plus 3 is a positive 8. This plus 8 and this plus 8 came from the same spot, plus 7, same spot. And now I have the two. I said I was going to go as fast as possible, but I'm still thoroughly explaining myself, aren't I? We have the change in x. We have the change in y. So I'll say that this was the change in y up here. So the change in y was equal to 7, and the change in x down here was equal to 8. And then we plug it into the Pythagorean theorem. So we come down here and say, okay, I'm ready. I have my a squared plus b squared is equal to c squared ready to go. I'm plugging in 7 squared. It doesn't really matter if it's 7 goes in for a or b. And I have an 8 squared. That's going to be equal to a c squared. Okay, 7 squared is 49. Plus 8 squared is 64, and that's set equal to a c squared. And then I know that 4 plus 6 is 10, but 4 plus 9 will carry over. That's 13. So it's 10 plus 13, or it's 110 plus 13, which is 100. Sorry, I said 100 plus 13. So it's 113 is equal to c squared. From there, I'm just going to square root, and c is going to equal to the square root of 113. I will give, that's the answer, but I'm thinking ahead here. I will give a warning that sometimes you do need to reduce your square roots. So I'm going to talk about that really quickly. So I know I'm out of room, but I still want to talk about it. Reducing radicals. If I have something like the square root of 8 is my answer, the answer key will not call this the square root of 8 because that is not reduced. The square root of 113 just happened to be reduced, and the square root of 13 also happened to be reduced because their factor trees were all reduced. What you need to do for each of these numbers, and this is something that we've already been practicing in geometry, you need to look at the factor tree. The square root of 8 is what? It's the square root of 2 times the square root of 4. And hey, look at this. The square root of 4, I can just cross you out and say you are equal to 2, which means the square root of 8 is 2 times the square root of 2, and that would be the final answer. So from now on, I've already said this before, but I'm repeating myself from 2 units ago. Anytime that you see a square root in my class, you must reduce the square root. You must reduce the radical to this form, not this form. All right, so I think that's everything, and I could end the notes there, but I'm going to be nice. I'm going to give you one homework solution for each of these just to show you how I would do it. And I want to go even faster. So I'm going to do this method where I'm going to use logic. I'm going to say, hey, I know how to get from negative 3 to positive 5. I go plus 8 and be done with it. I know how to get from negative 8 to negative 1. I add 7 and I'm done with it. I'm not going to do this long method, but if you ask me in class tomorrow when I'm back, I can do it the longer way to make sure that you thoroughly understand it. All right, we're doing a speed run. Here we go. So my name is Mr. Sindel, and I'm going to be doing problems. I'm going to randomly choose one and 7, the first of each type, to show you how fast I can go. It's not a race, but I do like showing off my mathematical abilities here. From negative 1 to 0, I go up 1, or go right 1 technically. From 8 to negative 6, I also go a positive amount, this time 2. And then I'm plugging into the Pythagorean theorem. I'm doing 1 squared plus 2 squared is equal to c squared. This would be 1 plus 4 is equal to c squared. 5 is equal to c squared. Oh, sorry. Yeah, that's right. Then I'm going to square root, and c is equal to the square root of 5. All right, I think that was a speed run enough. I want to check my answers, though. I want to be a good model student here. So I'm going to go back, and I'm going to say, oh, look, the answer was indeed square root of 5. So I can come back here, and I can highlight this one in green. Good job, Mr. Sindel. All right, speed run on number 7. How do I do number 7? Well, first I'm going to make that right triangle that I had in my notes. I'm going to say, okay, right triangle. This distance was, again, I'm going right 1, and then I'm going to go up 6 plus 6, and then I'm plugging that into the Pythagorean theorem. I say 1 squared plus 6 squared is equal to c squared. So I'm going to have 1 plus 36 is equal to c squared. 37 is equal to c squared. And finally, I'm going to square root both sides, and c is equal to the square root of 37, which I did a factor tree for in my head, and that has no factors. It is a prime number, so that must be the answer. That was a terrible rectangle though. Square root of 37 for number 7, square root of 37 for number 7. I come back over here, and I highlight my answer in green. So I could be done here. I'm going to give you one final hint on my way out, and I'll put it in the notes before I print them out for you guys. Whenever you're plugging into the Pythagorean theorem, for example, down here, these numbers will always be positive. If you accidentally get a negative by this step after you've done something squaring, you've done something wrong. And it makes sense that you can never have a negative, right? If I plugged in a -5 and I did that quantity squared, this is the same thing as -5 times -5, and the negative times a negative is always a positive. So by this step, you should never ever have a negative in geometry. All right, that is all I will leave you with. Thanks for watching. I'll see you guys later.